Hey everyone, welcome back to Code with Poonam. It's day 63 of our 100 days of coding challenge in JavaScript. Today's challenge is all about finding the maximum value in every sliding sub-array of a window size of a k. So let's proceed with this challenge and we will move towards our VS Code. If we see in the VS Code, we have here our question along with the sample input and output, okay? So let us read out this question. We have to write a JavaScript function to find the maximum value in every sliding sub-array of size k. And if you see here, we have been provided with the input that is an array and the k value, right? And in the output, we have the final output here, okay? So let us understand this question now. So let us come here and we will break down this question. So what we have to write? We have to write here what? JS function, okay? Now, what is the next important part of this question? That we have to find the maximum value in every sliding sub-array of size k, right? So that also I will take here and we will put it over here. Now, let us come to the line number 8 and we will define our function name, okay? Now, what we have to find? We have to find the maximum value in every sliding sub-array of size k, right? So we will come here and define our function as what? Find max in sub-array. This will be our function name with a parenthesis, okay? Now let us come to the line number 9. Let us understand this line number 9. What we have written, we have to find the maximum value in every sliding sub-array of size k, right? So now to understand this, we will come to our input and output, okay? So if we see in the input what we have been provided, we have been provided with an array. We have been provided with a k value. Now, why we have been provided with a k value? Because we have to get a sub-array of a size k. So that is why we have here our k. Okay, now, in this, if you come, there are total how many elements? There are total 7 elements if you see. So from 1 to 7 it is, right? So what is the length of this array? It is 7, okay? Now, in this 7 length, how many sub-arrays can be formed? If you see within sliding, this will be our first array, correct? Then if you slide it with the next element, this will be the next array. Then if you slide it, this will be our next array. And if you slide it, this will be our next array. And after that, this will be our last sub-array, right? So if you see here, how many arrays can be formed? It can form 5 sub-arrays, okay? With a sliding effect, okay? So now, if you come here, if this is our first subarray, 1, -2 and -3, right? So what is the maximum value? It is 1, right? Now when you slide -2, -3, -4, what will be the maximum value? -2. That is what you have here. Now if you again slide -3, -4 and 5, what is the maximum value? 5, right? Then again, if you slide -4, 5 and 6, what is the maximum value? 6. Now again, if you slide 5, 6 and -7, what is the maximum value in this subarray? It is 6, right? So that is where we have got our output in this form, okay? And the output is also in an array form, okay? Now we have understood that how we are able to get this particular output from this input. So now let us come down and we will write our approach as well, okay? So let me just write here approach. Now in this question, we are going to use our nested loop. Now what is a nested loop? A loop inside a loop is called as a nested loop, right? And this we have seen in our previous challenges as well, okay? In this question, we are going to take only 2 loops, okay? And what will be that? It will be I loop and a J loop, okay? So I will write here what? I loop and I will write here what? J loop, okay? Now, I loop will be our outer loop and J loop will be our inner loop, okay? So what this I loop is going to do? I loop will iterate over the static index of each sliding sub-array. So that is what we are going to do. So it will slide and it will iterate over each sliding sub-array. So let us come here and first we will understand our I loop itself, how we are going to write it. So we will write here what for and where it will start. Obviously, it is going to start at where I is equal to 0 because it's an array, right? So array is going to start at 0th index. So we are going to write here I is equal to 0. Now we have understood that there are 5 sub-arrays, right, in this. So I will just write here how many sub-arrays we have. 5 sub-array. That means it should run 5 times, right? Then only it will give me the 5 values, that to a maximum values, right? So we have to make sure this loop is running how many times? 5 times it should run. If you see it, you can see here once again, this will be our first sub-array. then this will be our second subarray, then this will be our third subarray, then this will be our fourth subarray, and then you will have your what, five subarray. That means it should run five times. Now we are starting our I is equal to 0, right? That means how much time it will run? Five times. So 0 to 4 is how much time? Five times. So that means where our loop should end, I should be less than or is equal to 4. So if you count 0, 1, 2, 3, 4, it is how much? Five times, right? So that is where we are going to write it, and we are going to increment it also. Okay. Now if you see, I have written what? I should be less than or is equal to 4, correct? But we will not hard code it. Why we are not going to hard code it? There is a reason behind it. Now we are working with respect to this particular array. If I give you some other array, then what? There might be a possibility, right? That it will increase the sub array count or it will decrease the sub array count, because the length of the array will not always remain the same, right? So that is why what we will do here is we will not hard code this. We will try to get some logic in place of 4. So if you observe here, what is our length? We already discussed our length of the array is 7. And what is our k value? It is 3, right? So if you subtract 7 minus 3, what you will get? You will get here 4 if you subtract it. So this is what we are going to use it. So in place of 4, we will write here what? ARR dot length we will write, and we will write here what? Minus k. Okay. So this will be our for loop. So our loop will start I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, and I is equal to 4. So there will be total 5 iterations happening, and this iteration will start over the starting index of each sliding subarray. So now let us come here and we will understand our inner loop also. That means our J loop. So I will write here what? J loop. Okay. Now we will write our J loop over here. So what we are going to write? For let J is equal to I. Now, why I am writing? Because if you see, whenever the value of our I is 0, this will be our sub array, right? As soon as it slide, this will be our second sub array. As soon as it slide, it will be our third sub array. So if you see, it is moving along with our I value. That is why J is equal to I. Okay. So now where it should stop, if you see how many times it should run, it should run 3 times, right? That is what is our logic here. Every time it is forming a 3 element sub array, right? So we have to make sure that it is running 3 times, correct? So whatever the value of I will be there, plus 3 I would do. That is what I am going to do. So if you see here, then what I will write here then? Whatever the value of I. So I am going to do here what? I plus 3 always, correct? Whatever will be the y, because I am starting with the I value. So if I is 0, then 0 plus 3 I am going to do. If I is 1, then I plus 3 I would do, because it will be 4, then 1 to 4 it will run. We will see this into our iterations now. I'm just telling you. So I plus 3 I will do. That means here in this case, what will happen? 0 plus 3 I will write. That is equal to 3, correct? So I need 3 iterations. We are getting it. Now in this case, I is okay. But what is our 3? 3 is nothing but our k, right? So we can substitute this 3 by k. And what we will write here? J should be less than I plus k. Here I will write. And I will increment this by j plus plus. Got it? Now let us understand the iteration. Okay. So when I is equal to 0, what will be the j value? J will be 0, right? Then we have our condition. J is less than I plus k. That is nothing but 0 plus 3. So that is equal to 3, right? So how many times this loop is going to run? 3 times. How? 0 to 2 it will run, and it will be how many times? 3 times, right? Now let us come down and we will see when I is equal to how much? 1, right? So what will be our j value? J will also be 1, and we will write here what? J should be less than 1 plus 3, right? Because it's I plus k, so 1 plus 3 we will write, correct? So I'll write here 1 plus 3, that is nothing but 4. So our loop will run from 1 to 3, right? That is nothing but our 3 times itself, right? Now let us come down and see when I is equal to 2. So what will happen when I is equal to 2? J will be also is equal to 2, and J will be less than 2 plus 3, right? That is nothing but what? 5. So our loop is going to run 2 to 4, correct? That is nothing but what? 3 times, right? So I'll write here 3 times. If you count 2, 3, and 4, it is 3 times, right? Now when I becomes 3, so I'll write here what? I is equal to 3. So what will be our j value? J value will also be 3. And what is our condition? J should be less than I plus k. That is nothing but 3 plus 3. That is what? It is 6. So the loop is going to run from which point? It is going to run 3 to 5. If you count, it is again 3 times, right? So I'll write here 3 times. So this loop is going to run again 3 times, correct? Now when I is equal to 4, okay, so I will write here I is equal to 4. Then what we will have our j value? J will also be 4. And then we will write here our condition. What will be the condition? 4 plus 3, that is nothing but what? 7, right? Now we will run our condition from 4 to 6. If you count 4, 5, 6, it is again 3 times, right? So I will write here what? 3 times. Now this is where our 5 iteration is completed, okay? Now I value is going to increase again. I is equal to 5, but our I condition it is going to check. And that is where the I condition fails and the loop will terminate here, okay? So that is why we will not be proceeding with further iteration because we are stopping here, right? At 5 maximum. So this will be our J loop. So this is how it is going to work along with our I loop. Okay. Now this is just we have understood the iteration with each sliding sub array. So we have understood how our I loop and our J loop is going to work, right? What is I loop doing? I loop is iterating over our starting index of each sliding sub array, and our inner loop is going to gather the elements of the current sub array. Okay, let us see how it will do it. Okay, so we will come here and what we will do now, we will write the logic, okay, for finding the maximum value from this subarray. This is just the iteration, right? This is not the end, right? We have to find our maximum value from the subarray. So I'll come here and I'll write here what? Find the max value, okay, from the sub array. Okay, so that is what I'm going to write here. Now what we will do, the first thing we are going to do it here, we will declare an temp variable and we will initialize with an empty array. Why we are doing it? Because here we are going to store our elements of the sub array. Okay, so that is why we are doing it. And by using what we will be doing it? By using our push method. Okay, so this method we will use it and we will push it to our temporary variable. Okay, that is nothing but an empty array. So we will keep pushing it. Okay, after pushing, what we will do, we will use our math.max method. Okay, so I will come here and I will write here what? Math.max method. Okay, and in this we will pass our temporary array. Now we cannot pass our temporary array directly. We will have to take help of what? Spread operator. Why? Because math.max method only take the values, direct numbers it will take, and it is going to provide you the maximum value. But here in this case, we have an array. So we will have to take the help of our spread operator. Why spread operator? Because it spreads out the elements of an array, right? So that is why we are going to use our math.max method, and in that we will pass our array along with a spread operator. So it will spread it out and it is going to give our what? Max value. So I will write here our max value. Then what we will do later on, if you see the output, it is in an array form, right? So we will have to come here and we will also declare one more empty array, and that we can name as result. Okay, so I will write here as a result and we will declare that empty array, and whatever the value we are getting it, we will keep pushing it inside it. So we will come here and what we will do, we will write here what? Result we will write, and we will use our push method, and whatever the max value will be there, we will keep pushing to that resultant array. Okay, so we will come and finally we will get our max value array from that sub array. So I will write here what? In this result we will have our max value from our sub array. So we will be getting our final output like this. So this is what we are going to do, and this is our final approach. So I hope you have understood the nested loop. You have understood how the loops are going to run, our I loop also, our J loop also, and then how we are going to find the maximum value from the sub array. Okay, so we will implement the same thing inside our function also. So let us come down and we will write our function. So let us come here and we will write our function and our function name. What is our function name? Find max in subarray. Let us quickly invoke it down. So I will write here what? Find max in subarray, right? And in this, we are going to pass our input array and the k value. So let us take it from here. And this is our input array and this is k value, right? K is equal to 3. So let us pass it to this. So I will write here this input array and I will write here 3. So this is nothing but we are passing as an arguments, right? So let us receive here ARR comma what? K, right? And let us come here and console it out. So console.log and I will write here ARR comma K, right? Now let us test it out in the terminal. So we will write here what? Node day 63 challenge and we will hit enter, correct? Now if you see, we got our input array and we got our K value also. So both the inputs we are receiving it here, right? Now let us come here and we will write our nested loop, okay? So what is our nested loop? First, we are going to start with our I loop. So we will write here what? For let I is equal to 0, right? And where it is going to end, we have written here, right? I should end at ARR dot length minus K, right? So we will come here and we will write it over here, okay? And we are going to increment it I plus plus, right? Inside that, there will be a J loop. So we will write here what? J is equal to what? I, correct? And then it is going to end at where? J should be less than I plus K. We have understood the iteration also, right? And we will come here and what we will write? Then I will write here J plus plus, okay? And we will come here and we will console it out our J value and our I value. Let us see. So I will write here what? Console.log and we will write here our template literals. I will write here I colon and let us write here dollar I, okay? And then we will put comma and then we will write J colon dollar J. Let us see what do we get in the terminal, okay? Let us come here and rerun it here. So we will clear the terminal. So we will write here what? Node day 63 challenge and we will hit enter. What do you get? See, for each iteration, it is going to run 3 times. When I is 0, J will run 3 times. When I is 1, again 3 times. When I is 2, again 3 times. When I is 3, J is again running 3 times. When I is 4, J is running again 3 times. So, and you can see 0 to 2. That is what we have written, 0 to 2. Then we have written 1 to 3. Same 1 to 3. Then we have written 2 to 4. You can see here 2 to 4 and you can match your I value also. It is matching it up. When I is equal to 3, 3 to 5, right? That is what we have done here. And then 4 to 6 also it is coming. And it is not running for I is equal to 5 because your I condition doesn't get satisfied and it fails, and that is why it is terminating the loop. So please pause the video here and understand one more time the iteration while doing this function, okay? Now we will come here and I will just comment this out for a time being, okay? Now let us come down and we will now find out our maximum value. So we will write our logic to find out the maximum value. So what we have to do? First, we have to declare a temporary variable and we will initialize it with what? Empty array. So let us write here what? Let temp is equal to an empty array, right? And we will come inside this by using a push method. We are going to store the value of J. So if you want to check it out, what is the J value? That also you can check it out by doing ARR of J, okay? I will just write here what? Temp dot push I will write, and in this what I am going to pass? ARR of J, correct? And this will be updating our temporary variable. That is nothing but our temporary array, I can say. So we can come here and we can console that out also. So console.log temp, you will find your temporary sub array. So let us come here and we will clear the terminal and we will rerun it. Node day 63 challenge and we will hit enter. So you see you are getting your sub arrays. This will be your first sub array. This will be your second sub array, third sub array, fourth, and this is your 5. So you are getting totally 5 sub arrays. You can see here clearly from here and it is ending at here, and you can understand it. This was our first, then second, then third, and this was our last, right? 5, 6 and minus 7. You are getting it till the last. That means 5 sub arrays we are able to get it. Now in this what we have to do here, we will come and we will find our maximum value by using our math.max method, right? So let us declare one more variable as a max val, okay? So we will come here and we will write here what? Const max val is equal to, we will use our math.max method. So I'll write here math.max. And in this, using our spread operator, we will use our temporary array. So I'll write here like this, and we can console our max value also. So let us come here and console it out. Let us see, do we get or not? So console.log, I will write here what? Max val. So we will get here in the terminal what? The values, right? So let us come here and clear the terminal and rerun it. So I will write here what? Node day 63 challenge, and we will hit enter. See, what do you get? When this was your sub array, it is 1. When this is your sub array, it is -2. When this is your sub array, it is 5, right? And when this is your sub array, it is 6. When this is the last sub array, it is 6, right? You can match with this your final output: 1, -2, 5, 6, and 6. So you're getting the exact values what has been expected, right? But this is in an array form, right? So that is why what we decided, that we will declare a empty array and we will start pushing it to that empty array, right? So we will come here at the top and we will declare an empty array here. So I will write here what? Let result is equal to empty array, right? And we will come here, and whatever is the max value, we are going to push it to our result array. So I will write here what? Result dot push, and I will write here what? Max val. Okay, that's it I'm going to write. Now just let us comment all the console.log statements and we will see what is the output we are getting. Okay, so let us comment this out and let us comment this out also, and let us save it. Okay, let us come here and we will check it out, but we haven't consoled it till now the result. So we are not going to get our result, right? So we will come here and we will console that as well. So console.log, and we will write here what? Result. Okay. Now let us come to the terminal and test it. So I will clear this out and we will write here what? Node day 63 challenge, and we will hit enter. What do you get? 1, -2, 5, 6, and 6. Let us check our output. See, 1, -2, 5, 6, and 6. So this is nothing but our final output array. We are getting this, correct? Now let us come here and we can just improvise this. So I will write here what? Maximum values of the sub array. Okay, so let us write here like this. So I will write here what? Maximum values of sub array. Okay, let us write it and rerun it one more time. Okay, sub array colon we will write, and let us clear it and we will rerun it. So we will write here what? Node day 63 challenge, and we will hit enter. So what do you get? You got your maximum values of an sub array is 1, -1, 5, 6, and 6, right? So this was our final approach which we have implemented inside our function also, and we are able to get it also. You can try out with a different arrays also. It is going to work. Okay. And even if you want to change your window size, you can also change the window size to k is equal to 4 and 5. It's up to you. That is why we have written this logic by using our k value. Otherwise, we would have hard coded it, but we have not hard coded it. We have used our k value wherever it was necessary. Okay, that is why we will not be able to get anything wrong here. So let us come here and we will invoke it one more time and we will pass another array. Okay, so let us write here 23, 45, 67, and 89. In this, how many sub arrays can be formed? Only 2 sub arrays, right, of a window size of a 3. Let us come here and let us pass here only 3 once again. Okay, so let us test it out one more time in the terminal. So I will write here what? Node day 63 challenge, and we will hit enter. What do you get? See, 67 and 89. We are able to get from this maximum value and from this maximum value. Okay, let us invoke it one more time and we will change our k value also. Let us see that out also. So I will write here find max in sub array, and we will come here and we will pass 79, 45, 78, 90, 34, 23, a big array I'm writing here, and we will write a window size of 4. Okay, let us come here and we will clear the terminal and rerun it one more time. So I will write here what? Node day 63 challenge, and let us hit enter. What do you get? 90, 90, 90. Let us see. Our k size is 4. So if you see here, what is our first sub array? It is this one: 78, 45, 78, and 90. What is the maximum value? 90. You get 90. Correct. Now in the second sub array, when you slide it up, so this will be our 4 window size. Here again, you can see 90, correct? And again, if you slide it up, what is the maximum value? 90 in the subarray. So every time it is 90 only, that is where we are getting here 90 as our subarray. If in place of 23, if I would have written 100, no, then you would have got 90, 90 and 100. Let us test that out. So let us come here and we will invoke it one more time and we will pass 100 in place of 23. So let us put it here and I will write here what? 100. Okay. So remove this 23 and write 100. So let us come in the terminal and rerun it one more time. Note day 63 challenge and hit enter. See, you got 90, 90 and 100. So if you see in your last sub array, you are getting 100 as your maximum value. That is why it is getting updated. So if you see, it is working out with the different combinations with a different k value. So even if your window size is different, it is going to work. So this logic will work with whatever the length of the array and with whatever your k size will be. That means our window size will be with a sliding sub array. So it is going to work out. So that's what this question was demanding from us, and we have done that successfully also. So now let us come here and we will have a quick recap of this particular question. Okay. Now, if you see here, what was our question? We have to write a JavaScript function to find the maximum value in every sliding subarray of size k, right? And we had our input and output as well. So we understood how to reach to this particular output, right? Whenever we were sliding it up, we found out the maximum value, correct? And then we reached to this particular output, correct? That is what we understood. Then we broke down this question and we wrote at line number 9 our JS function. We defined the JS function as what? Find max in subarray with a parenthesis, right? And then we wrote here what? Find the maximum value in every sliding subarray of size k, correct? So from line number line, we wrote our approach, correct? So in this question, we understood that we will have to use a nested loop, that too only two loops, right? That is I loop and J loop, right? And how many times I loop is going to run? Only 5 times, correct? So we didn't hard coded it. We wrote here arr.length minus k. So that is where our I loop is going to stop. So what is outer loop? That means I loop doing, it is iterating over the starting index of each sliding sub array, correct? Then we understood how the J loop is going to work. So since the window size was 3, we have to always make sure that it is running 3 times internally. For that also we wrote our logic, right? I plus k, correct? And then we understood the iteration. So we understood that I is going to run only 5 times, right? 0 to 4. And when I becomes 5, it will terminate. And hence our internal loop also terminated, right? And that is where we completed our all the iterations here. And once we understood the iteration, then it was very easy to find out the maximum value from the sub array, correct? Then we declared a temporary array and we stored the sub array element inside the temporary array, right? By using a push method. Then how we can get our maximum value? We can get by using our math.max method, right? And in that we were passing our array but using a spread operator, correct? We cannot directly pass the array inside our math.max. That is why we needed a spread operator, fine. So we got here our maximum values, but if you observe your output, it was in an array form. That is where we again had to declare an empty array and we pushed our maximum value to that result array, correct? And that is where we consoled it and we got our final resultant, and the same thing we wrote inside our function. So we came here at line number 32 and we wrote our function name as what? Find max in subarray. Then we consoled it out and we tested out and we created result as an empty array to store the final output inside this. Correct? Then we wrote our for loop. Both the loops we have written I loop and J loop, right? And here we wrote the logic for pushing inside a temporary array, and we wrote here logic to find out the maximum value from the sub array, right? So finally at line number 45, we stored everything into our result array. That is nothing but our final output, right? So whatever was the maximum value, by using our push method, we pushed it to that array and we got our final resultant at line number 47. We also improvised it, right? Maximum values of sub array colon and we wrote our result, right? So from line number 49 to 59, we have passed different input values, correct? We changed our array. Also, we changed our k value. So both we have seen, right? And if you test it in the terminal, we are going to get our correct output. So let us clear the terminal and rerun it one more time. Note day 63 challenge and we hit enter. So we are getting our final resultant array, right? So 4 times we have invoked and we are getting the proper 4 times correct output, right? So what we have done guys here, we have used our K to determine how many elements are to be considered at a time. This solution uses a brute force approach by evaluating all the possible subarrays of size K and by using Math.max method with a spread operator, and is a powerful and a concise way to find the maximum value. That is what we have done. Now, why this challenge is important? Because it helps us to understand the sliding window technique, which is a crucial for optimizing solutions to problems involving sequential data. It also improves our problem solving skills and prepares us for coding interviews where logical algorithm challenges are common. Okay. So in day 62, guys, we have solved the problem for finding the minimum value in every sliding sub array of size k. The approach is quite similar to this one where we used our math.min method and we passed our temporary array using a spread operator to find the minimum values. Today we have adapted the logic to find the maximum value in the sliding subarray. So take a look at day 62 also if you have missed out. And that's it guys for today. So keep coding, keep learning, stay consistent, and I will see you tomorrow with another exciting challenge. And also don't forget to like, share, and subscribe. And thank you so much, guys. Take care. Bye bye.